Can everybody hear me? You can, okay. I hope everybody can understand me. I'm Scottish, so apologise in advance. Now, I need to cut this a bit short, we're running a bit late, but if you look up my website, Stirrup.com, I'll put the slides up there. And so, because we're running a bit short, I've decided to dispense with all the data science jokes. And the reason for that is that most of them, well, half of them are below average. The reason I present is so I can reflect my sense of humour on as many people as possible and hope that at least one person finds me funny. So data analysis is something we can do in R and in Python and probably very often in Excel, bless. So what I'd like to do is show you a bit of a different way you can do R and use R and Python to help you with that. Now there's already quite a lot about R and Python on the internet. Gene Wilder, we had to put it up unfortunately. He passed away this week, so that's my little homage to him. So I wanted to talk to you a little bit about what I see in organisations is a bit of a melting pot where everybody uses different technology. Everyone's got a little empire, so some people will use R, some will use Python, some will use SQL, some people will use Excel and probably not admit to it, which means it's on their hard drives. Following on from Steph's topic, infrastructure is important because people are not backing up their things. So first of all, what is Python? Well, mainly it does very many different things, but it has a library of machine learning algorithms. You can do all sorts of really fancy things with it. It is open source, and it has a number of APIs as well you can use. So it's very accessible, and I'm going to show you some R code and some Python code and how they correlate with each other. So coming back to my earlier point, in real life, in organisations, we tend to see things looking like this. I tend to see organisations not having much of a technical blueprint about how everything should knit together. So the thing is, if your data is siloed, the analytics are siloed as well. So organisations have very vertical views of their data. You have the marketing data, the finance data, the purchasing data. So that means it's very easy for organisations to answer the question, what happens if I get 5% increase in sales in my department? They can give you an answer for marketing, for example. But what they can't do is give you a view of that 5% across the whole organisation. It becomes very difficult to get a horizontal view of the data. And the reason for that is we start to end up in the scenarios like this. It's a bit of scrambled eggs. So something I've gotten really interested in recently, and it's still in development, but I wanted just to mention it, something called Apache Arrow. It's now a top-level Apache project, so you can go and sign up with the site. The reason I find this so interesting is because, coming back to our R and Python original question, sometimes we actually have a bigger question at play, is how do we start to make these languages talk to one another so we can make the best advantage of them. Now, there's lots of open source projects out there, as you know, which ones do we actually go for. But the interesting thing is the developers from Python, Pandas, Cassandra, other projects are actually involved in this one as well. So it seems that the state, big data technology, is moving forward at the moment. People are starting to realise actually we need to get these things to talk to one another. So they're saying in a few years, maybe about 15% of the world's data will be processed through Arrow. And Arrow, really, just to define it, is a high-performance interface between various systems, and they're doing it in Python at the moment. So the idea is that we no longer have our scrambled eggs environments with lots of pots of different technologies really driving the enterprise data. What we're trying to do is have Pandas as a Python library, Python API. We want those to be able to talk easily to the different data sources. So we can answer our enterprise question of what is 5% increase in sales mean across the whole organisation. So finally, organisations will have a horizontal view of their data across the organisation without trying to spend 2 years building a data warehouse or something like that. So the advantage of Apache Arrow at the moment is that it's between 10 and 100 speed up your workloads. I'm mentioning this specifically because two are heroes of mine are working on this. So Wes McKinnon is a big Python guru, and Hadley Wickham is working on this as well. They're both working on packages called Feather, and I think the fact that you've got such a big R guru and a Python guru working together sort of really indicates the importance of trying to think what's the next step in terms of data technology. So what Arrow does is it's enabling execution engines, so it allows you to use really modern processors in terms of compressing the data. It allows the data to be laid out in a columnar fashion, and that's better for compression because it just means systems can look down the column a bit better. If you use something like SQL Server and analysis services, for example, it uses low compression, and that's a bit harder to search through because there's more variety in the data. So how does the code actually look? So here we have it in R, and you can go and import the Feather library, and what we've got there is a read Feather, so that opens up a pipe to the data, reads in the data, and sends it to a variable. So that's a very simple piece of R, which you can see in the left-hand side there. So there's the same code in Python. So if you can read this, you can read that. You should be able to extrapolate one from the other. So that's a little piece of Python code there. I'm sorry I'm shooting through this. I'll put this slides up. So just a little bit more about Feather. I recommend you go and have a look up about this. As I say, Hadley Wickham is one of the best things he's working with. So Feather's fast and lightweight. It's basically got the data in a binary format, and it's using binary format to store data frames. And it's got a few design goals. It's basically a very lightweight, minimal API for pushing data in and out of data frames. And it's doing it as simply as possible. And as we know, when we're dealing with data, if you keep things as simple as possible, it reduces points of complexity and points of failure as well. And it is language agnostic, so Feather files are the same whether they're written in Python or in R. It just gives you another tool to control it, I think. So it means that we can start to worry a bit less about the languages and worry a bit more about how we're doing it. And coming back to the scientific methodology, I personally, when I'm doing things for customers, I try and stick with the CRISP DM model. It's something that I can show to a business person, and it starts to break it down for them and they understand it. If you've never looked at it before, I'll put the link up on my site. There's a lot of information about this. It's just basically a methodology that translates the technology and demystifies it for the business professional. And that's always a really, really good thing to do. So what is Python? It's more of an interpreted language, and it's very high level, which means it uses many layers as it goes up and down the application stack down to the network layer. So that can mean because it is doing that, it can be a bit more intensive if you're using graphics. So what have they got in common? Well, they're both very popular for data analysis. They're both free. R, since we're here, has a long and trusted history, and it has a lot of support as well. I should do Google Trends actually, do that for next time, I think. So Python, I think personally, is really good for crunching through data. If you're familiar with more functional programming languages, you'll pick it up very easily, I'd say. It's good for doing the really mucky, dirty things of data, and we all see that. And I've always thought to myself that if you don't find dirty data in the environment, it's because you're not looking hard enough. It won't be there, just somebody's hiding it, and maybe deleted it even, which might be worse. Alright, so choosing between them, I'd say that Python doesn't have as many packages and libraries as R. It doesn't mean it won't have in the future, just at this moment in time. It does have a lot of great tools though, such as pandas. You can use Seaborn for visualizing data as well. So it's a lot of really nice things and really nice tools that go with it. So what I find in my own experience is that people from a maths and a stats background tend to prefer R, but computer scientists tend to like Python. So it depends on your background as well. The whole "it depends" usually answers. And if you have got a lot of really dirty data, then if you look at it in Python, then analyse it in R. So there's no reason that you couldn't use both together. So I'm going to put the slides up, so I'm just going to zoom quickly, just so I can show you some of the equivalent commands. So how many minutes have we got? 6 minutes, all right. So just some very simple examples, just something we're all familiar with. So they both have working directories. So we know that that's the R command. So we have very similar commands here. It reminds me of, in the old days, DOS, Unix commands more. So that's probably why more computer scientists were familiar with it. You can use IPython, which is a notebook, in order to play with the data. You can also set up Jupyter notebooks. You can do that in Azure as well. So if you're interested in just getting something up and running, look at the Azure implementation. It's in the cloud, but if you have a Microsoft Azure subscription or an MSDN subscription, you can get it with a certain amount of credits. So that's always something to think about. Now, they both have data frames. So what we do here is in Python, like in R, we have to import a number of libraries, NumPy, and then we've got MD Pandas one, which is really about crunching through data. We already know what the R one is, and we already deal with data frames there, and that concept applies also to Python as well. And we can do very similar things with the data frames. I've put in some SQL as well for those of you that are familiar with SQL. I keep meaning to do a series of blog posts that correlates all three. I should try and do that one day. So say for example, just to pick in an example, that you want to see the top, the head of the data, you've got the head command. You also have the head command in Python, just to give you a bit of a snapshot of it. And if you were doing SQL, that would be select RockstaR. So there are very equivalent ways of interrogating data. So we can also inspect our data because that's an interesting thing to do. I quite like doing that, obviously. So it's easier to do in R and in Python because it's a really nice, very concise language. Both of them are, I think. If you want to do the same thing as SQL, you've got the average command, so there's different implementations of average in SQL. Min and max, median can be a bit harder to get. Obviously, you sort it first and then find the one in the middle. So we can select our data as well. So we've got the select star command in SQL, and then we've got it's very, very similar to do it in Python as in R. We're using square brackets again in order to try and finalise which data we actually need. And we've got a number of very, very similar functions. So R, you know these ones, I'm looking for square root, the logarithm, the mean and median. They're very, very similar in Python. So if you're using this, you can also use that, just to try and get a feel for your descriptive statistics. So you can also visualize the data as well. People might look at it and think, okay, so I've done my analysis in Python, I'll go back to Excel to visualize it. Well, actually, Python itself has got some really nice data visualization, as does R. So if you are looking at, alright, so it's just on the right-hand side. Sorry, I've not updated it for R, I just obviously copied the slide. My fault. So just data visualization. I get so excited about the name before it. I forgot about this one. So you can see here, as we do a box plot in R, it's more or less the same command to do it in Python as well. They're very equivalent. So what I recommend you do is take one of the brilliant data sets out there, go play with it, install Python, give it a blast, and see what you think. So my name is Stirrup. If you're on Twitter, if you look up the Saturday hashtag, I'll put this in my blog and you can download the slides and read that at your leisure. So with that, any questions?
Thank you.